Hi guys! So for this video, we will discuss logarithm. So the discussion for logarithm is adjacent to the discussion of exponents since logarithm and exponents are related to each other. Aside from that, it is important for us to remember these basic concepts related to logarithm and exponents. Because for us to understand the concepts behind calculus or differential equation or other higher mathematics subjects, we need to understand the basics first. And that includes logarithms and exponents. Okay, so let's start. First, we have the definition of logarithm. So logarithm is a quantity representing the power to which a fixed number or base must be raised to produce a given number. So aside from this definition, logarithm is important because it is one way to conveniently express a large number. Instead of writing the entire number, all of its digit, you can express it into its logarithmic form. That way, it will look shorter as well as simpler. Okay? So for us to understand this definition, we need to look at the differences and similarities of logarithms and exponents. So for us to understand the differences and similarities of logarithms and exponents, we need to look at the general format first. So for logarithm, the general form is log x base z equal to y. And for exponents, the general format is z raised to y equal to x. Okay, so looking at the general format, we can now see the similarities. The similarities are the components involved in these equations. So if you look at the logarithmic form again, you will see that the components are x, y, and z. And those are the same components that you will see in the exponential form, x, y, and z. So let's define those components. Z represents the base, y represents the exponent, and x represents the power. So that's it. That's the similarities of the logarithm and the exponent. So technically, the logarithm is a complement of the exponent. So you can rewrite your logarithmic form into an exponential form or vice versa. You can rewrite an exponential form to its logarithmic form. So it depends on the type of problem that you would like to solve, if it's in logarithmic form or exponential form. So that's the similarity. Now for the difference of these two are the results. As you can see in the logarithmic form, the result is always the exponent, y. But for the exponential form, the result is the power, x. So it depends on what you would like to get. If you would like to get the value of the exponent, so you should use the logarithmic form. But if you'd like to get the value of the power, so you should use the exponential form. Okay, so that's the relationship between logarithm and exponents, their similarities and differences. So now let's discuss the different types of logarithm. So the types of logarithm depends on the base. The base can be a number, a real number, it can also be a variable, it can also be an imaginary or complex number. But for this video, we will discuss the three specific types of logarithm that are commonly used in mathematics problem. The first one is the common logarithm, which is the base 10 logarithm. The general format is log x base 10 equal to y. So this is named common logarithm because this is the most commonly used type of logarithm, especially for algebraic problems. This is the type that we usually use. Okay, so the next one is the natural logarithm, which is a base e logarithm. So the general format is log x base e equal to y. Or it can also be written as ln of x equal to y. The base e represents the Euler's number, which is approximately 2.71828. So natural logarithm is commonly used in problems related to calculus and higher math, especially in trigonometric identities and trigonometric functions. We usually use natural logarithm for that and also for complex numbers. Okay, so that's the second type. And the third type is the Naperian logarithm, which is a base 1 over e logarithm. So the general format is log x base 1 over e equal to y. Okay, so the Naperian logarithm is a special type, a very special type. This is not commonly used in problem solving, except for problems that specifically require Naperian logarithm. But for most problems, we only use common or natural logarithm. Okay, so that's the three types of logarithm that you need to familiarize.